All right, let's look at the back page. Let f be a twice differentiable function defined on the interval from negative 1.2 to 3.2 with f of 1 equals 2. The graph of f prime of x is shown below, the derivative of f. The graph of f prime crosses the x-axis at negative 1 and 3, we can see that, and has a horizontal tangent at x equals 2. And let g be the function g of x equals e to the f of x. As I was walking around, we weren't using g of x correctly. That's a very important part of this problem. Write an equation for the line tangent to the graph of g at x equals 1. To write the equation of a tangent line, we have to write the equation of a line. Y equals m, x minus x1 plus y1. Let's go ahead and fill it in. We know that we want it when x is 1. So let's go ahead and put that there. To find y1, we need g of 1, which would be e to the f of 1. From the function, we know that f of 1 equals 2. So our y value, g of 1, should be e squared. So I'm going to go ahead and put that right there. Then the last thing we need is our slope. Our slope would be g prime at 1. So to do that, we need g prime. G prime of x, the derivative of e to the x is e to the x. So the derivative of e to the f of x is e to the f of x times the chain rule, f prime of x. And if we want that at 1, g prime of 1 is e of f of 1 times f prime of 1, which is e squared times negative 4. F prime of 1 comes from our function. So we had this discussion in class. I would leave it as negative 4e squared times x minus 1 plus e squared. I wouldn't put the decimals in there. If you know the exact value, leave it in exact value. So part B, for the entire function, negative 1.2 to 3.2, find all values at which g has a local maximum. So again, g of x is e to the f of x. In order for that to have a maximum, hi Maddie. So to find when g of x has a maximum, we'll set its derivative equal to 0. Again, g prime of x is e to the f of x times f prime of x. Set that equal to 0. Now, this isn't what numbers do I put in where? It's a recognition, and a lot of AP problems are like this. This will never be 0. E to any power, even if it's negative 100, is always going to be a positive number. So really, we're only concerned with f prime of x. Where is that 0? That is 0 at negative 1 and 3. So g prime of negative 1 is 0. G prime of 3 is 0. So those are the only two options to have a maximum or a minimum. So we look at it. When we do our second or our derivative test, if I put in right before negative 1, g prime is going to be positive because this is positive and this is always positive. So positive, and then afterwards, f prime is negative. So this is going to be negative here. And then if we look at 3, same way, it is negative and positive. Which one represents a maximum? if we are increasing and then decreasing, we have a maximum. So saying that we have a max at x equals -1, hi Nathan, because f prime of x is greater than 0, and then f prime of x is less than 0 before -1 and after -1, that creates a max for g of x. In C, they give us g double prime, and they want to know, is g double prime of -1 positive, negative, or 0? So let's put the -1 in. E to the f of -1 is always going to be a positive number. E to the f of -1. It doesn't matter if e to the f of -1 is -100. It's going to be a positive number. So let's keep looking inside. F prime of x squared. And if we put the -1 in there, if I look at the graph of f prime of -1 is 0. 0 squared is still 0. And then last, plus f double prime of -1. So the slope of f prime, what's going on with the slope of f prime right here? It is decreasing, so all that we care is that that is a negative number. 0 plus a negative number is a negative number, times a positive number is a negative number. Therefore, it's going to be g double prime at -1 is going to be negative. All right, and last D, find the average rate of change of g prime of x, the derivative of g, over the interval 1 to 3. So average rate of change, g prime of 3 minus g prime of 1. What was it at 3? What was it at 1? Over 3 minus 1. G prime of 3 is e to the f of 3 times f prime of 3. F prime of 3 is 0 minus, we already did g prime of 1 above, that is -4e squared divided by 3 minus 1, which is 2. So our final answer should be 4e squared over 2, or just 2e squared should be our average rate of change of g prime.